right, 2.4, we're talking now about linear inequalities. And a linear inequality means that they are unequal instead of equal. So this is where you see inequality signs. This one means greater than or equal to, less than or equal to. Those are inequalities. And so to start out with, let's just make sure that we understand what their notation means. So let's graph and write them in something called interval notation. We want to be familiar with that and be able to use that easily too. So they're going to give you something that looks like this. You'll see the squiggly brackets and you'll say then x, and then it has a straight line. And this straight line is actually shorthand, and it means is such that. So this is saying x is such that x is greater than or equal to 2. And then they'll close their parenthesis. So let's make sure that we understand that. If I wanted to graph that, what you need to do is draw a number line and put the one number or the two numbers, whatever numbers you're dealing with, on that number line. So I'll put 2 there. Now it's saying that x is greater than 2 or equal to. So greater than means I'm talking about this is negative infinity and this is infinity. So if I were, this would be 1, this would be 0, this would be 3, and it just goes 4, 5, 6, 7 forever. So if I'm telling them numbers that are greater than or equal to 2, I'm talking about these numbers over here, right? 2, 3, 4, 5, up to positive infinity. Now it says or equal to 2, so I want to tell them that I'm including 2. And a lot of students have seen the solid circles for that, and I like that, but for some reason math has gone, instead of a solid circle, they use what we call a bracket. And the benefit of that is that it will lead us into interval notation. So these are equivalent. This is a closed circle and this is a bracket. Brackets are like closed circles. So that means it's equal to 2 and greater than 2. And you'll see why they kind of are handy when we talk about interval notation. So now let's write it in interval notation. Interval notation means I write the starting point and the ending point. And so I'm always using the smaller number for the starting point. So the smallest number it includes is 2, and then it goes all the way up to infinity. So since we're including 2, I use a bracket. And that's probably why they've gone to this on the number line, because then it's easy to write interval notation. However, I can't actually ever reach infinity. No matter what number I give you, 1,020, you can tell me 1,021. If I say 1,059, you can say 1,060. So you can never reach infinity. So the notation we use that says getting as close as we can get to infinity, but never counting it, is a parenthesis. And that is interval notation. Let's try another one. How about this one? If I tell you that x is such that x is less than -1. So now, on my number line, I would just have -1. And then I need to figure out which side to shade. So I know that I'm counting from negative infinity, -1, then this would be 0, then this would be +1, and so forth. So if I'm talking about numbers less than -1, then I'm talking about this side of -1. Let's see, was this my -1? I'm talking about this side of -1, right? So going from negative infinity all the way up to -1. But look, this one does not include it. This one says x is less than -1. This one said greater than or equal to. So without that equal to not line, we're not including it. So it will have a bracket. It would be like an open circle in the past. So starting with my smallest point, always go left to right, smallest to largest. The smallest point is negative infinity, and I go all the way up to -1, and I don't include -1, so it has a parenthesis. Alright, let's try solving some equations. So, for example, they will say solve and give you something like this. X minus 2 is less than 5. Now, we just did these with equal signs, so this isn't hard because the rules are identical. The same thing you do. If I'm solving, I need to get the variable x alone. So I do the furthest thing from x, which is the 2, and I do the opposite operation. So I add 2 to both sides. So I get, here the 2's cancel, and I get x is less than 7. But here's the additional step. Now I need to graph it, so I put it on a number line. I draw that 7. And then this is nice. If your x is first, you always shade the way the arrow points. So if I know x is less than 7, I know I'm shading 6, 5, 4, 3, all the way down to negative infinity. And then to write my answer in interval notation, I start with the smallest point, which is that negative infinity, and go up to my ending point, which is 7. And I know I'm not including 7 because it's not equal to, so it's a parenthesis, both there and on your graph. And we can never include infinity or negative infinity, so it is also a parenthesis. Alright, let's try this one. How about if I give you some algebra to make sure we're good on? So I'm going to give you a negative inside of parentheses. And let's see if we can solve this inequality. So we're going to begin by that lovely word distribute. We're going to distribute here and here. And so make sure you go all the way through the parenthesis. So it becomes negative x and positive 3. And then on the right side, we're going to distribute the 3. So again, it will be 3 times that and 3 times that. So I have 6x minus 15 plus x. Now combining like terms, and hopefully this is all just review. So far nothing's new, and I've got 7x minus 15 over here. Now I need to get the x's together, and so you can pick. Let's go ahead and deal with that negative. So I'm going to subtract 7x from both sides. So I get negative 8x, and you know what, in that same step, and here they cancel, in that same step, let's go ahead and take the 5 over here. So let's subtract 5, just getting our x alone. So I have negative 20. And you can do that in 2 steps if that's easier as well. Now this brings up an important new concept. When you divide by a negative, it makes the opposite true. So in other words, if I divide by a negative, negative 8 divided by negative 8 is 1, so that's gone. But now I have positive 20 over 8, right? Because a negative over a negative is now positive. So what happens is, let's try just a basic problem. Let me do this problem. What if I tell you that 2 is less than 5? But then, we know that's true, right? We know that 2 is less than 5. But let's say I did times both sides by negative 3. So I have 5 times negative 3, and I have 2 times negative 3. So I'm multiplying both sides by a negative. So now I have negative 6 and negative 15. Now, which one's smaller? We know that this is way more negative than this, so it's way smaller. So look what happens. My arrow flips. So what used to be bigger becomes more negative, so it becomes smaller. So this is an important rule. Anytime you divide both sides by a negative, you have to remember to flip your arrow. And I'll call it an arrow so that you don't get it mixed up with the positive and negative sign. And reduce like always. So 2 goes into that twice, and 2 goes into that 4 times, 10 and 4. And then one more time. Let's go 5 halves. Okay? And so that's our final answer. But we're not done until we write it in interval notation. So let's write it, graph it. So I'm graphing 5 halves, and I know that it's greater than or equal to. So I'm shading to the right, and it's a bracket, isn't it? Because it's or equal to. So my smallest, my furthest left point is 5 halves, and I go all the way to infinity, which I can never include. So that's your final answer in interval notation. That's what they'll be wanting. Let's do one more. This is the last one. Let's do this one. And so, you know what? I'm going to use this paper because it only has a tiny bit taken out of it. Alright, let's say I have to solve this. So the directions say solve, and in the problem you will see an inequality, and so instead of an equal sign, a greater than or less than. So once again, we begin by distributing. Then I need to combine my x's, and so getting my x's together, whether I'm taking them to the right or the left, I will subtract 2x from both sides, won't I? And so, my x is gone. Now we saw this before. This is big. Whenever your variable cancels, do you remember what you do? I have 6 is greater than 1. If the variable is gone, I look at the statement and go, okay, is it true or false? Is 6 greater than 1? And that is true. 6 is greater than 1. So because it's true, that means, remember before we wrote all real numbers, because no matter what we put in for x, it will be true. Well now, because it's all real numbers, if you were graphing it on a number line, here's 0, you would graph negative infinity to positive infinity. Everything would be included. And so the way we state it now is we say our answer is negative infinity to positive infinity. That is interval notation, okay, for all real numbers. Let's just do one more. Make sure we've got this down. Let's do 2 divided by 5 times x minus 6 is greater than or equal to x minus 1. Now, some people like to distribute that, which is totally fine. If you're good at that, do it. But then we're going to have, when we distribute it right here, we'll have 12/5, and I just hate dealing with fractions. So what I'm going to do is I'm going to get rid of that 5 right from the beginning. And we know that this is something times something, so it's actually all one term. Because if it's in parentheses, it doesn't, terms, I should tell you this, terms are separated by plus or minus signs, but they have to be not, let's write that capital, not in parentheses. So I know if I times by 5, I have to multiply every single term by 5. This one, but here, this is all one term. Here, this is 2 terms because there's a minus sign in between. But here, there's no plus or minus sign except the one in the parentheses, and it does not separate terms. So this is all one big term. So when I times by 5, I just have to do it once, and it's gone. So I now have 2, and I'm going to distribute 2 times x minus 2 times 6. And over here, I have 5 times x minus 5 times 1. Okay, let's keep going. So let's get x alone. So let's take x to the right side just to be a little different this time and to keep it positive. So here is gone, and I've got negative 12 is greater than or equal to 3x minus 5. And you can do it either way. You can subtract 5 from both sides. Just don't forget that when you divide by a negative, to flip your arrow. The way I did it, I'm going to go ahead and add 5 to both sides. So I've got negative 7 is greater than or equal to 3x, and now my 5's are gone. And then we have to divide by 3, and 3 is positive, so we don't change our arrow. But what I wanted to show you is that when x is on the right, it's a little bit different when you graph it. Because if I were going to write x first, I would write x, and then look, it's pointing to the x. So I would point it to the x still. And then my big part is to the 7/3, and I would keep that big part to the negative 7/3. So those are equivalent, and you would have this if you took your x's to the left side. And when you divide, you flip your arrow. Or you would have this if you did it like we did it and took our x's to the right side. But now writing it in interval notation, let's graph it. So I have negative 7/3, and it doesn't matter what the number is, just put it on the number line. And then if I'm looking at this one, I would say x is less than, because the little arrow is pointing, this is the less space, right? X is less than negative 7/3. If I had it this way, I still say x is less than negative 7/3. And so either way, you read that x is less than, x is less than. And so less than it means the left side towards negative infinity, right? So in interval notation, my answer should be negative infinity, which always has a parenthesis. And in this case, I'm going to include negative 7/3, so it has a bracket. So I go all the way to negative 7/3 with a bracket. And that is your answer in interval notation. Good luck with 2.4. If you have any issues, text me and I'll work those out for you. Hang in there, you guys. Good luck.